Microwave communication uses free space radio links operating from UHF through EHF, practically from about 1 GHz up to 45 GHz. These are generally point-to-point links where a transmitter focuses a narrow radio beam toward a distant receiver. Line of sight is critical. Physical obstacles like trees, buildings, and mountains must be avoided, and the Earth's curvature limits the maximum distance between towers. The hopping distance, meaning the maximum distance between two towers, depends on the carrier frequency. At lower frequencies like 6 GHz, hops can reach about 70 kilometers. At higher frequencies like 18 or 45 GHz, hops shrink to around 8 kilometers because higher frequencies suffer more atmospheric absorption. Rain, fog, smog, and humidity all weaken microwave signals. Despite these challenges, microwave links remain essential today for telecom backbone connections and increasingly for 5G mobile backhaul, where millimeter wave frequencies at 28 and 39 GHz use the same fundamental principles we are about to study. The key formula in microwave design is free space loss, or FSL. FSL quantifies how much a signal weakens as it travels through open air. In decibels, FSL equals 96.6 plus 20 times the log of D plus 20 times the log of F, where D is the distance in miles and F is the frequency in gigahertz. For example, a 1-mile link at 5.825 GHz has an FSL of 96.6 plus 20 log of 1 plus 20 log of 5.825, which equals 96.6 plus 0 plus 15.3, giving 111.9 decibels. But FSL alone does not tell us if a link will work. We need the received signal level, or RSL. RSL accounts for the complete link budget, the transmitter output power P sub O in dBm, minus cable losses at the transmitter and receiver, plus antenna gains at both ends, minus the free space loss. The formula is RSL equals P sub O minus LCTX plus GATX minus LCRX plus GARX minus FSL. RSL tells us the actual signal strength arriving at the receiver. Every receiver has a minimum signal strength it needs to work correctly. This is called the receiver sensitivity threshold, or R sub X. A link is theoretically feasible if the received signal level is greater than or equal to the receiver sensitivity threshold. In other words, RSL must be greater than or equal to R sub X. But just barely meeting the threshold is not enough in practice. Path fading, caused by atmospheric conditions, can temporarily weaken the signal below normal levels. Fade margin is the safety buffer between RSL and R sub X. Fade margin equals RSL minus R sub X. A higher fade margin means the link can withstand more fading and therefore has higher availability. For example, a fade margin of 18 decibels might give 99.99% availability, while a fade margin of only 10 decibels might drop to 99.9%. In flat, humid environments, fading is more severe, requiring larger fade margins. In rough, dry terrain, fading is less frequent. Let us work through a complete link budget calculation step by step. Given a 1-mile microwave link at 5.825 GHz, transmitter output power is 1 dBm. Both antennas have a gain of 26 dBi. No cable losses for simplicity. Receiver sensitivity threshold is minus 77 dBm. Step 1. Calculate FSL. FSL equals 96.6 plus 20 log of 1 plus 20 log of 5.825. 20 log of 1 equals 0. 20 log of 5.825 equals 15.3. FSL equals 96.6 plus 0 plus 15.3 equals 111.9 decibels. Step 2. Calculate RSL. RSL equals 1 dBm plus 26 dBi plus 26 dBi minus 111.9 dB. RSL equals 53 minus 111.9 equals minus 58.9 dBm. Step 3. Check feasibility. RSL of minus 58.9 dBm is greater than R sub x of minus 77 dBm. The link is feasible. Step 4. Calculate fade margin. Fade margin equals minus 58.9 minus the quantity minus 77 equals 18.1 decibels. This is a comfortable margin providing excellent link availability. Let us review. Microwave links operate from 1 to 45 GHz as point-to-point line-of-sight connections. Higher frequency means shorter hop distance due to atmospheric absorption. Free space loss. FSL equals 96.6 plus 20 log D plus 20 log F in decibels. Received signal level. RSL equals transmitter power plus antenna gains minus cable losses minus FSL. A link is feasible when RSL is greater than or equal to the receiver sensitivity threshold. Fade margin equals RSL minus R sub x and determines link availability against atmospheric fading. These same principles apply to modern 5G millimeter wave backhaul. In the next lesson, we will cover wireless access technologies, MMDS, LMDS, wireless local loop, WLAN, and Bluetooth.